look at graphing logarithms. First of all, remember, we cannot take logs of 0 or negatives. So that means we're not really going to have a whole lot of graph on 0 or on the negative side. All right, our first example here is log base 6 of x. Okay, we have to think about a couple of points we can plug in, and we were practicing this yesterday. So the first number I want you to plug in is a 1. Log any base of 1 makes a 0. And log base 6 of 6 makes 1. So I got a couple points here we're going to investigate. Let's zoom in a little bit. The first thing we're going to look at is the point 1, 0. So we do have an x-intercept. And we have the point 6, 1. Do you think we're going to have any y-intercept? Is there going to be any graph on the y-axis at 0? Well, no, because we can't take the log of a 0. So there's going to be an asymptote right here. And what about graph over here by all these negatives? Do you think I can plug negatives into a log? Absolutely not. So just scribble that all out. There's going to be no graph there. I'm going to look for your scribbles tomorrow. So what does a log graph look like? It's going to approach the negative y-axis here as an asymptote, closer, closer, closer. But then it kind of takes a sharp bend like this and almost looks like an L. And as you go over, it does rise, but very slowly. Okay, let's take a look at the next one, log base 10. In most instances, they do not even type the base 10 because this one's called what? A common log. Common log, base 10. You won't even see that a lot of times. So let's plug in 1. Any log of 1 is going to make a 0. Let's plug in a 10. Log base 10 of 10 is going to make a 1. Okay, and do you think we could put negatives into this equation? Absolutely not. So he's also going to have a asymptote on the y-axis. Okay, there's going to be no graph over here. 1, 0, 10, 1. Okay, so same thing. Asymptotic to the y-axis comes up. Now you got a curve over here, kind of curve like a sharp bend, and it does rise, rise, rise. Put an arrow. It keeps going forever, all the way to positive infinity. Okay, the last graph we're going to do here, what's the name of this one? This one right here. This one's called the natural log. Natural log. And the base for a natural log, everyone, is e. What's natural log of 1? 0. Natural log base e, and if I put an e in, that's going to make a 1. So I've got the point 1, 0, and e is approximately how much? 2.718. So let's go 2.7 and up 1. So here is what the natural log curve looks like. Okay, they all look pretty similar, up, up, up to the right. They all have these asymptotes on the y-axis. Okay, unlike the exponential graphs, who had asymptotes on the x-axis, these ones are going to be going up and then curving over. Okay, what about logs whose bases are between 0 and 1? Okay, so the base is a fraction. Well, very similar to what happened with our exponent graphs. These ones are going to be, sometimes people call these decay. Sometimes they call these decay. Okay, let's take a look at the first one here. If I plug a 1 in, does not matter what the base is, you're still going to get 0. And if I plug 2 in, that's weird. Some people say, well, why don't you plug a half in? Okay, we can. We can plug a half in because that would make a 1. But what if I plugged a 2 in? Maybe we should try a calculation. Log base 1/2 of 2. I know that I can write that 2 a different way. Let's write that 2 as something to the negative power. I'd have to reciprocate that and make a half. If you have a base 1/2 of a half, the answer is going to be -1. Okay, it's just going to make it a little bit easier to graph. So let's take a look at this. 1, 0 is that point right there. You can go a half to the right and up 1, but sometimes that gets a little tight, and I don't really have much over here. So if I plug 2 in, and you get your negative point, that does help draw the curve a little bit better. We have an asymptote on the y-axis. So these graphs are going to be asymptotic to the positive side of the y-axis and then take their bend over here. Okay, so if you'd like to plug in the 1/2, the fraction, that's okay, but I also suggest plugging in the reciprocal so you can get a whole number. All right, let's try another one. See if you got the idea. First of all, log base anything of a 1 makes a 0, so we have that point. And then if we plug in 5, that's going to make -1. So plugging in 5 gives you so definitely gives you something to aim for. If we plugged in 1/5, then we'd get 1, but that doesn't really help me over here on this end. And we have to make sure we get the right growth going over here. So we're going to be asymptotic to the positive y-axis, take our sharp bend to the right like this, and look like a log base 1/5 of x. Now, I know that I said that the asymptote's on the y-axis. Is it always on the y-axis? Well, not if you start shifting it around. And that 0.1, 0, that could get shifted around as well. So let's take a look at some reflecting, and then we'll do some shifting with our logs. Okay, so first of all, let's take a look at these examples right here. They go across the page. These two examples are linked together. So this is log base 3 of x, and then this one's going to have something happen to him. Okay, so first of all, let's go over here. This base is 3, so this one is going to be growth. And the 2 points that we should plug in, always plug in 1, and then plug in, same as the base, plug in a 3. Okay, so he's got his asymptote on the y-axis. We've got 1, 0, 3, 3, 1, and here is our log graph. Now, what does this equation want us to do? It's the same base, log base 3, but if the x is negative, if there's a negative by the x, that's going to be a reflection over the y-axis. The x-axis would be out in front. It's kind of like, think back to chapter 2 when we did negative x. Inside is y-axis. Out in front would be out here. So here's a picture for you to look at. Here's the y-axis. It happens to be an asymptote. So anything on the right is going to get flipped to the left. 1, 0 goes to -1. And 3 to the right is now going to go 3 to the left up here. So here's what the curve is going to look like. Asymptotic down, and then curve, curve, curve over that way. All right, let's do some more. Again, these two are linked. Let's just draw a little line here on the page. Make sure you do that so I know you watched my video. We're going to take a look at the point 1, 0 and e, 1. Okay, this is just a regular natural log here. We cannot put a negative, so we're going to have an asymptote right here. 1, 0. 2.7, 1. So here's the natural log graph. And what does this one want us to do to that? A negative out in front means reflect over the x-axis. X-axis. So take a look at this curve. Anything above is going to be going below. So is it still going to be asymptotic to the negative part of the y-axis? No, it's going to be going up the y-axis. Are we still going to have that point 1, 0? Yes, that'll still be there. When we reflect over the x-axis, where does e, 1 go? Well, it goes to e, -1. Okay, so reflecting him over the x-axis, it's going to go up, 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 and shoot over here to the right. All right, let's take a look at log base 1/4 of x. Okay, 1/4 of x, and then something special is going to happen to it. So first, let's graph this one. A couple of points we should plug in is 1, and the other point you should plug in, we should plug in the value 1/4. 1 is going to make 0. 1/4 is going to make 1. Oh, that's going to be kind of tight. Maybe there's another number we should plug in, similar to the base, but the reciprocal. What if we plugged in 4? You guys know what that would make? Yeah, -1. Okay, so let's draw this one where the base is a fraction. So we've got 1, 0. 1/4, 1 is tight, but 1, 2, 3, 4 negative. Oh, that definitely helps me draw it the right way. So here is log base 1/4. Now, what do they want us to do with this one? when the negative is inside near the x. That's going to be which axis reflection? Yes, the y-axis. So let's take everything over here. Anything on the right is going to get flipped to the left side. So the entire graph is going to be on the left. We've got negative 1, 0. We've got negative 4, negative 1. If you'd like to plug that little fraction point in right there, you can. And there we go. Now this is weird because I thought we couldn't do log of negatives. How in the world is this graph even working? Because you can't put a negative into a log. Anybody figure it out? There is no graph on the positive side. The graph's here. Wait, you can tell me I can plug negative 1 into this equation because a negative makes... that's why the graph's on the left, all by the negative side because the negatives will cancel out. In this case, there's no graph on the positive side. Okay, everything's coming together nicely. Let's see who remembers Chapter 2. Inverses of exponents are logs. The inverse of log is exponent. They undo each other. They go back and forth. If you get stuck in exponent form, you switch it. They're inverses. They undo each other. Who can remember what the graphs look like? They're reflections of each other over what line? What line? Y equals X. Were you thinking of that? Okay, we're going to graph these two right here. We're going to graph these two, and we're going to show you how a log and an exponent are inverses of each other. The first thing I want to do is graph the line y equals x so we could see how they reflect. Okay, let's talk about these because we're kind of putting two things together. This first equation right here, this is an exponent. Is this exponential growth or decay when the base is big? That's going to be growth. Exponential growth. Okay, now I need to find some points. The first thing you're going to plug in, can you put a 0 into a power? Absolutely. Anything that a 0 power makes 1. And then the next point we're going to plug in is 1. 2 to the first power makes a 2. Do exponent graphs have any asymptotes? Yes, they do. The asymptote for exponential graphs is the x-axis. Unless it gets shifted up and down, but it's definitely going to be horizontal. Now, let's talk about the stuff you just learned. Let's talk about this. This is going to be a log graph. Points that you can plug in. Numbers, can you put 0 in? Absolutely not. Absolutely not. You can plug 1 in. Log of 1 makes 0. Look at that. Look at how it's switched. That's because they're inverses. The other number we're going to plug into a log is the same as the base, 2. Log base 2 of 2 makes 1. Look at that. Okay, do log graphs have any asymptotes? Let's look back at our notes here. I think log graphs do have asymptotes, but it's not the x-axis. It's the y-axis. Yep, look at that. Everything is switched. Okay, let's get our purple pen out here and draw an exponential growth. 0, 1, 1, 2. Make sure you got the x-axis asymptote. Exponential growth starts off slow and gets bigger. We could even plug in 2 and get 1, 2, 3, 4. Try to aim for that point 2. And the log graph, he's asymptotic to the y-axis. He has the point 1, 0, 2, 1. Here's his asymptote. He goes like this, shoots on over like that. If you folded your paper, they should match exactly. Inverses. All right, and now we're really going to see who knows what they're talking about because I need to know how to find an inverse. There's 2 steps. 2 steps to finding an inverse. The first step, switch x and y. Switch x and y. We're going to practice this. We're going to take this log equation right here, and we're going to find the inverse. So instead of saying y equals, let's say x equals log base 2 of y. Okay, and now what's step 2 to finding an inverse? You have to solve for y. Okay, we got to get that y out of there. How do you get a y out of a log? I cannot subtract it. I can't divide. He's stuck in a log. Oh, he's stuck, you say? In a log? Well, then let's switch to exponent form. We'll do a log circle. 2 to the power of x equals y. Did we get the same exponential equate? Yep, we did. These guys are definitely inverses. Okay, the 2 steps to finding an inverse. You switch x and y, and then you solve for y. Okay, also good review for our final because we did learn how to do this earlier in the year. All right, our last example here is to graph with some shifting. I'm going to answer all these questions after I see it. But I think what would be a really good idea is to first just graph a basic one. So take out a pencil or a black pen, and let's do y equals log of x. Let's just do the basic one that's not shifted 4. This one has no base. Must be a common log. So there's a couple points we're going to plug in. 1, and that gives us 0. Then we'll plug in 10, same as the base, and that gives us 1. Okay, and where's the asymptote for this guy? It's going to be on the y-axis. So we've got 1, and then we've got 10. 10, comma 1. Okay, so here's the basic one. Or you could do a dotted curve even, that would be nice. Okay, now let's go do our real problem. I'm going to do the real problem here in light blue. Okay, so I'm going to take this curve, this basic common log, and I have to do something to it. This 4, which is really close to the x, means 4 units to the right. So everything is going to get moved 4 units to the right. So does that asymptote still stay there? No, that asymptote goes 1, 2, 3, 4 units to the right. Does the point 1, comma 0 stay? No, that point has to go 4 to the right. 1, 2, 3, 4. That's going to be on 5, comma 1. And the point 10, comma 1 needs to go 10, 11, 12, 13, 14. Oops, this point goes here. 14, comma 1. So now the log graph looks like this. It should be underneath. Everything got shifted over. It's the same common log, but 4 units to the right. All right, how about the domain? There's a couple ways you can do this. You can do it algebraically, which we've learned before by looking at the of. X minus 4 has to be greater than a 0. So x has to be more than 4. Is my graph greater than 4, not touching 4? Yeah, because 4 is the asymptote. So the domain is x is greater than 4. You can look at the visual, or you could do the algebra. How about the range? Smallest y. Definitely negative infinity. What's the largest y? I know it's growing slowly, but it is going over and up, over and up. So this one is definitely all reals. And the vertical asymptote is at 4. Wait, that's not the right way to write a vertical line. Don't forget x equals. X equals. Okay, the video is now going to end, but your notes are not. I need you to practice finding an inverse, and then I would like you to graph that exponential equation and the inverse log that you find on this piece of graph paper here. And I'm going to check this tomorrow. Good luck!